Hello everyone, today we are going to discuss a question from our general physics assignment. I am Penny. Now look through to the question. Ali is moving a billiard ball with a mass of 170 grams on a table with a height of 1.5 meters from the floor by using a rod. Look through to the picture for our apparatus setup. Move on to the first question. What is the acceleration of the ball if Ali apply 1 Newton of force push the ball by using the rod, assuming that the coefficient of friction between the ball and the rough table is 0.25. First, we need to calculate the frictional force between the billiard ball and rough surface table. From the question above, we know that the mass of billiard ball is 170 grams, which also equal to 0.17 kilogram. Now, we can calculate the frictional force by multiplying the coefficient of the frictional force and the normal reaction. We know that the normal reaction equal to mg, which is 0.17 multiplied 9.1 F, equal to 1.6677, also equal to 1.67. So now we can calculate our frictional force by multiplying 0.25 with 1.67. We can get our frictional force is 0.417 Newton. The force is equal to 1 Newton minus 0.417 Newton. The answer of the force is 0.583 Newton. We know that force equal to ma, so our ma also equal to 0.583 Newton. From this answer, we can know that our A multiplied 0.17 equal to 0.583 Newton. So we can get our A by divide 0.583 to 0.17. We can get our A is 3.43 meter per second per second. So our acceleration of the ball is 3.43 meter per second per second.
Thank you, Penny. Let's move on to part B. Determine the velocity of the billiard ball when it collides with the tennis ball. So, we know that the initial velocity of the billiard ball is equals to 0. So, in order to solve these questions, we can use one of the equations of motion, which is v squared equals to u squared plus 2as. v squared 0 equals to 0 squared plus 2. The acceleration from part A is 3.43, and the distance of the billiard ball and tennis ball is 2 meters. v squared equals to 13.72 meter per second. v equals to square root 13.72, and v equals to 3.70 meter per second.
Thank you, Yinghan. So now we will move on to question C. Assume that the billiard ball stops after it collides with the tennis ball with a mass of 58.5 grams. Calculate the final velocity of the tennis ball. To calculate it, we will use this formula. m2 u2 equals to m1 v1 plus m2 v2. The mass of the billiard ball is 0.17 kg. The mass of the tennis ball is 0.0585 kg. The initial velocity of the billiard ball is 3.70, and the initial velocity of the tennis ball is 0. The final velocity of the billiard ball is 0. So now we need to know the final velocity of the tennis ball. And this is how we solve the question. Next, we will move on to the question D. The tennis ball will continue its moving until the ball reaches the ground. Calculate the time taken for the tennis ball to reach the ground. For finding the vertical velocity, we will use this formula. To know the height is provided in the question. It is 1.5 meter from the ground. So now we know the height is 1.5 meter, and the gravity is equal to 9.81 ms, I believe too. So now we will substitute in the value. and this is the vertical velocity. Next, we will use this formula to find the time. The initial velocity is equal to 0, and we know that the acceleration is the gravity, so it is 9.81. So now we'll substitute all the values. The time for the tennis ball to reach the ground is this.
Thank you, Shenqing. So let's move on to part E. Ali wants to place a pill with a diameter of 60 cm at the point that the tennis ball reached the ground to catch the ball. The center of the pill must be at the same position with the point that the balls reach the ground. How far should the pill place from the table A? So to solve these questions, we have to find the range between the table and the pill. Range equals to US times T. The final velocity of the tennis ball is 10.75 times the time that we get from part D is 0.553 equals to 5.945 meter. 5.945 meter is the distance between table to the center of the pill, so we have to minus the radius of the pill equals to 5.945 meter minus the radius of the pill. 5.945 meter minus 0.3 meter equals to 5.645 meter.
Thank you, Ihang. I'm Keishan. Let's move to the question F. If the tennis ball is replaced by a basketball with a mass of 0.55 kilograms, does the position of the pair A should be changed to catch the ball? If yes, please state the changes and explain your answer. First of all, we know that the mass of the basketball is greater than the mass of tennis ball. And according to the principle of conservation of momentum, we know that m1u1 plus m2u2 equal to m1v1 plus m2v2. The value of m2v2 of the basketball is always the same as the value of m2v2 with the tennis ball. So when the m2 increases, the v2 value will be decreases. And we know that range is equal to vs times t, and the t will be constant. Vs value decreases, our range also will be decreases. So the ball will reach the ground at a position which nearer to the table. Now we know that the value of A will be changed because the value A should be decreases, so it can catch the ball successfully. Due to the range decreases, the PL should also place at the position nearer to the table. Now, let's move on to the question G. If the tennis ball is replaced by a 1 kg block, will the block move when the billiard ball collides with the block? Assume the coefficient of static friction between the block and the rough table is 0.3. Now, we need to calculate the frictional force between the block on the rough surface table first. Frictional force can be calculated by the coefficient of static friction between the block and the rough surface table, and then multiply with the normal reaction. Then we know the value of the coefficient of static friction is 0.3 and R equal to 1 times 9.81. Then we know we can get the value of frictional force, which is 2.943 newtons. Besides that, we know that the force acting on the block equals to the force on the billiard ball, because they will collide with each other. According to the question A, force is equal to 0.8 newton that they will add on the block. Since force equal to 0.583 is smaller than the frictional force, which is 2.943 newton, then the block will be stationary and at the same position. It's because the frictional force of the block on the table prevents the block to be in push